Alright, I've got a ton of blue. Alright, so today what we're going to look at is solving exponential and logarithmic equations. We're going to start with something very simple and in exponential form. When I see something in exponential form, I want to change it to log form or logarithmic form. And I do that by putting the log down. I take the base of the exponent, make it the base of my logarithm. Take the answer to the exponential equation, put it right after that.
What?
Then you take this, which we've done before, we just haven't put a name to it. You do log of 3 divided by log of 2 equals x. What you are doing here is actually has a name, and it's called using the change of base formula. When you put log of 3 divided by log of 2 into your calculator, you get that x should equal 1.585. Typically we're going to round to the thousandths place. This became 1.58496, which would have meant everything goes there. So you'll put 10 there. That's your rounding to the thousandths place, or 10 thousandths place. Round to 10 thousandths. So this is a very basic two-step equation. Change to log form. Use the change of base, approximate your answer right there. Now, second example, the only difference is that we've got something more in the exponent. As far as where the things go and what you do, same steps. This is exponential form. We're going to rewrite it in log form, which means that I put down a log. The base of my exponential term becomes the base of the log. The answer to the exponential equation becomes after the log. And it's going to equal the exponent, which is x plus 4. At this point, what you want to use is the change of base. So you have log 101 divided by log of 3 equals x plus 4. Type that into your calculator, being careful to remember both the parentheses and the division sign in the middle. And you end up with 4.2008 equals x plus 4. And the great thing about these calculators is you do not have to hit clear here. Don't clear it out and put this in your calculator. Keep your answer more accurate by just doing -4 on your paper and hitting -4 on your calculator. It'll automatically subtract it from the answer. You end up with 2.2008 equals x. Okay. The last type of homework you'll see, the last type of problem you'll see on your homework is going to be something like this, where it just says evaluate. And it'll say evaluate using the change of base. So using the change of base, we know that this is going to be log of 7 divided by log of 2. Again, come to your calculator. Log of 7 divided by log of 2. 2.8074. And again, round to the 10 thousandths place. This is very simple. This is stuff we've done before. After these types of problems, you we'll see one more. One more type that looks like this. Log of x minus log of 3 equals 8. Now here we don't simply have one log, we have two. But yesterday, using properties of logarithms, we had a great way to combine this into one logarithm. So your first step is going to be to try and combine all these into one logarithm so that you can then rewrite it in exponential form. Okay? So we're going to call that simplifying. First step, simplify. If I have a minus, I'm going to use the quotient property, which means that I can rewrite this as log of x divided by 3 equals 8. So my subtraction, when I simplify, I go from 2 logs to 1 log. I do x divided by 3. And here's the other piece that we have not gone over yet. If I want to rewrite this in exponential form, what I need to know is what is the base. And just like with a square root, we had an invisible number of a 2 as the index. Here, there's really an invisible number. Plus, when I don't write a number, the base is 10. This whole piece right here, log base 10, is called the common log. It's called the common log because we don't have to write the base. But in order to rewrite it in exponential form, I need to know what the base is, because the base of the logarithm becomes the base of my exponent. So I have 10 to the 8th. Remember, the exponent is over on this side, equals x divided by 3. Ten to the 8th. You could do this just by adding 8 zeros, or having a total of 8 zeros. Just like 10 squared, you have a total of 2 zeros in 100. If I wrote a 1 and 8 zeros, I'd be fine. We're going to use scientific notation here to get x by itself. We're going to multiply by 3 to cancel those out. And here, we're going to multiply this by 3, but instead of getting 3 and then 8 zeros, I would prefer that you write it as 3 times 10 to the 8th equals x. Now if the number is smaller, you should actually do this math here, okay, and get just a simple number. But when you have something in the millions or tens of millions, you will just use scientific notation. That covers all 4 types of problems you'll see on your homework tonight, and best of luck.